So that's how you find the area between two curves, is you do top curve minus bottom curve. So we would go 0 to k of 4 minus f of x. And we want that to equal the area we get when we go from k to 2.3, doing 4 minus f of x. So you just have to write an equation that says that. So we want, when we integrate from 0 to k, the area of top curve minus bottom curve to equal the area when we go from k to 2.3 of top curve minus bottom curve. And that's all you have to do on that part, is say that you want the area of the first half from 0 to k, and remember to do area between two curves, top minus bottom, to equal when we go from k to 2.3, top minus bottom. And this is worth 2 points.
Is the bathroom open?
I don't know, but if it is not, one of these two keys, one of these two keys opens it, and I can never remember which one it is. Even though I made them go in the keyring to face opposite directions, I could try to remember. I always pick the wrong one. Alright, so this is worth 2 points. And we'll take a break after this one, so if y'all want to use the bathroom or anything, you can. So 1 point for the area of one region, which is the 4 minus f of x, and 1 point for the equation. Okay, so I'll take a break for a second, and then we'll do another one of these area volume ones. Figure out which one we're going to do next. Huh? Alright. So next, after we take a little break, we'll do the 2013, number 5. Yeah, this is no calculus. Which is only a problem on part A, because part B and C, they just have you set it up. You don't actually have to work it out. But part A, trying to work this one out, because it's got trig in it without a calculator. You can't imagine, like, I think this is the second year that they did it. I think in 2012 they also, no, in 2012 it was on the calculator part. In 2011 it was the non-calculator part. Yes. I'm going to show you all that trick, the little square root trick that will help you with this one. Or the hand. 2013, number 5. 2013, number 5. So this is the non-calculator portion, which is not really a big deal except for part A. Because part B and part C, they don't make you work out the problem anyway. You know, just set it up.
You can skip parts and still get points for the
Yes,
other part.
yes. You can still get the point for part B and C on this one, even if you didn't do part A. I would at least try to set up part A and get those points, because you may not be able to remember all your trig to actually completely work it out, but you can still set it up. Like, the setup is not terrible. Okay, so the number 5, it says let f of x equal, and then it's got f of x, and g of x equal, and let R be the region bounded by the graphs of f and g as shown in the figure. Okay, so can you tell which one is f and which one is g? Because you don't have a calculator to type them in and figure it out, and they don't tell you. And it's important because we got to know which one's top and which one's bottom.
The bottom one is the first equation?
Yeah. It's a parabola that opens up, right? 2x squared minus 6x plus 4 is a parabola that opens up. So this one has to be f of x, which means this has to be g of x. Right? So even if they give you 2 and one of them is kind of a nasty equation, they should give you one on that you can figure out what it is. It should be a function that you should be somewhat familiar with what it looks like. So, okay. So find the area of R. So we talked about before, I think it was before Danielle got here, and I know it was before you got here, Cameron, that to find the area between two curves, that's what it's asking us to do. You integrate top curve minus bottom curve. And the bounds for your integration are the x coordinates of their points of intersection. Right? So this is where they start intersecting to create the area, and this is where they stop intersecting to create the area.
That's what we had to plug in the calculator, right?
Yeah, that's what we did.
And we don't have a calculator.
So not a calculator. Yeah, that's why this is kind of a pain, is to work. But if you can at least set it up, right, and you can set this up without actually, I bet that you'll get at least 1, if not 2 points for just setting it up. So to set this one up, we would do, that's why it was important that you could tell the difference between which one was F and which one was G, so you could get your setup right. So we're going to integrate from 0 to 2. Right? Their first point of intersection is at 0, and the second point of intersection is at 2. And the top curve is g of x. And you can just call it g of x. You don't have to write the whole equation. They've defined what f and g are in the problem, so you can just call them f and g. So you know what you're talking about. D of x, right? Now, for us to actually work it out, we do need to use g and f. But just for the setup, which let's see how much the setup is worth on this one. Let's see what the setup. Oh, hold on. I'll say that's not this year. 2013. Let's see.
One of them almost hit me yesterday. I was like backing out, and like this car, like I was backing out, and there's like a line of cars behind me. So like the car stopped, so I could get out. And this lady, she's like, hey, and then like whoosh, it just like stopped immediately. She told me backing out, and it's like honked at me, and I was like, I was cutting out. And then while that was happening, I was trying to like, then I was going straight, and it was her name Diana. Diana sees her friend on the other side of the parking lot and runs straight in front of my car.
Did you almost threaten to break
And I had to like brake, and I was like, oh my god! And she was like, you almost hit me! And I was like, right in front of my car. I was so mad.
Okay, so we would get a point for that. But hey, a point is a point.
You get 1 point?
Yeah, we.
And you need like 14 to get a 3? Is that what we're recording?
Oh no, you need like 20 something to get.
Whatever.
I was
Yeah.
so mad.
I got this.
But this is, and then the other two parts, parts B and part C, where you don't actually have to work it out, are worth 3 and 2. So this part's actually worth a total of 4 points. Just setting it up is 1 point, right? So just setting it up on this part would be 1 point. So okay, so now to get the other points, we actually have to figure out what this is. So we have to integrate G, we have to integrate F, and we have to plug in 2 and 0. Right, so, alright, so I'm going to try integrate G first. So I'm going to go ahead and plug in here. If you actually work it out, the rest of this is worth 3 points. So this is 1, working it out is worth 3. I personally probably would, like, set it up and then move on. And I would come back to this part if I had time later. But anytime I see one where it says write but do not evaluate, write but do not evaluate, I want to do those first. Because I'm not actually going to have to work anything out. All I got to do is set it up. And then I would come back to this one. Okay, so G of x is 4 cosine 1/4 pi x, which is going to be the one that's a pain to integrate. Yeah, or use substitution. Minus 2x squared minus 6x plus 4. Okay, so let's start with the 4 cosine. That's the hard part. We'll do the part and then we'll do the easy part. So alright, so I'm going to say that u is 1/4 pi x, right, the inside, which means that du is 1/4 pi dx, right, because a number times x, the derivative is just the number, and 1/4 pi is just a number, which is like 2x, the derivative would be 2. 1/4 pi x is 1/4 pi. So we need to turn a 4 into a 1/4 pi. So we have to multiply it by, I'm trying to figure out what they did. So to get 1/4 pi, we need to multiply by pi over 16. Right? That would give me 1/4 pi. I'm going to integrate these separately. So confused with what it is. Okay. Wait, no. Oh yeah, no. Okay. So I have to balance that with 16 over pi on the outside. 16 over pi. So I'm going to be integrating, I'm just going to ignore the 0 and 2 for right now. I'm just going to worry about 16 over pi times the cosine of u. Because this pi over 4 or 1/4 pi goes away when we integrate because it's part of the derivative. Right? So we just have cosine of u. Which means I'm going to get 16 over pi sine u, or sine of 1/4 pi. Right. That's the hard part, is integrating that part. Right. And then to integrate this part, we just add 1 to the exponent, divide by the new exponent. Right. This was worth 2 points, figuring out the antiderivative. So before we even plug in, alright, because we haven't done anything with the 0 and 2 yet. This is worth 2 points. And then now we would have to plug in 2, plug in 0, and subtract. Now the good news is when you plug in 0 to each of these, they're both just 0. Because if you think about it, if I plug 0 in here, remember this big square root trick? The sign of 0 is 0. Right? So if I plug 0 in, this will be 0 because the sign of 0 is 0. If I plug 0 in here, this will be 0. So I don't really have to worry about plugging in the 0 because I'm just going to get 0 anyway. I just need to plug in the 2. So 16 over pi sine of 1/4 pi times 2 would be 1/2 pi, which would be pi over 2. So the sine of pi over 2, square root of 4 over 2, would be 2 over 2 or 1. Alright, this is the sine of pi over 2, which is just 1. Right. Sine of pi over 2 is just 1. This is just 16 over pi. Minus, and then if I plug in 2 here, I get 16 thirds minus 12 plus 8, which would be 36 thirds, 24 thirds. So negative 20 plus 4, nope, minus 4 thirds. What did I do wrong? Oh, subtract, right? Subtract positive 4 thirds. Yeah. This is only worth a point, figuring this out. So all of this work to get 16 over pi minus 4 thirds is only worth a point. Yeah. So, like I said, I would have been content to get the point for setting it up and moving on. The average that people got this year on this one, let's see, number 5, 4.14 points. So the parts B and C are worth 5 together. They were 3 and 2. If you got the point on setting this one up, you would have 6 points, and the average is only 4. So this would be about average. I would imagine that a lot of people did not get all the points for this part because it's a huge pain to do that. Okay, parts B and C are a lot better. So let's look at parts B and C so we can kind of turn this problem around. Because part A was a mess. Okay, part B. Write but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 4.
Is that the washer?
Yep, that's the washer thing. Yep. So here's the line we're going to rotate around. So it's going to go around this way. Alright. So it makes kind of like this, like, kind of curved on the outside, little bowl kind of a shape, right? Because it would go like this. Something like this. It's really hard to draw. Right. But it would be something like that, right? It would rotate this shape around this way and make kind of this bowl with like a curved inside and kind of a curved outside. Does that kind of make sense? Again, it doesn't really matter. All you need to be able to do is figure out outer radius and inner radius. Is really the main thing, but kind of helps at least when you're first doing these problems if you can kind of picture what you're doing. So we are going to do the washer method. So remember the washer method says we're going to do pi, and we're going again from 0 to 2 of outer radius squared minus inner radius squared. Right. So outer radius squared minus inner radius squared. This is the outer radius. This is the inner radius. Because you're doing a circle, and the area of the circle is pi r squared. So they'll always have pi on the washers. It's common for people to forget the pi, so sometimes they'll make pi like a point all by itself, like that you can still get the point for the rest of the problem, even if you forget the pi. Okay, so the outer radius, that would be from our axis so that we're rotating around, so from this y equals 4 to the edge of the area that's furthest away from that axis. Now, this is the first time that we've measured an axis. The last problem we did, we were measuring up. So this is a little bit different. Any ideas on how to figure out what that distance is? 4 minus d of x, yes. Because you're measuring down from 4, right? So you're starting at 4, and the distance from the x-axis
to that